Laws 1.5. Our first law we have to talk about is going to be the addition law. So basically, this one's going to be called the what do we call this one? Same bases. So bases are the same, and you're multiplying. Those are the two conditions that you need to have in order to use the exponent law. Okay? So, if you have these, you can use the exponent laws. Okay, so the first one, did I go up too high? Product. The product law. Product law means you must be multiplying, bases are the same. That's what this one's called. So, example. That's what number one's all talking about. This is the example for number one. Okay, the example for number one. Okay, so we've got 7 exponent 4 times 7 exponent 6. That's going to give us 7 exponent 10. Because I've got the same base, I can add my exponents. So my 4 and my 6, I'm going to add them. Okay, and that's how I get my 10. That's called exponent form. We're just going to write notes on our own right now. You could have bases that are in brackets. If brackets are attached, touching each other, that means multiply. So, in that second example, it's going to give us a to the 5th times a to the 7th. No, it's 7s today. Because those brackets are sitting side by side, they do mean multiply. They're not going to show you the multiply sign. They expect you to know that means multiply when they're side by side. Again, because I'm multiplying, bases are identical. Okay, so same base. Okay, remember your two conditions, same base, and you're multiplying. That means now you add the exponents. So my final answer will be a exponent 12. Now, the exponents can be letters sometimes too. They don't have to actually just be digits. They could actually be a variable as well. And that's what some of the examples show. So I'll do another mini example with just variables. Next example, all variables. So again, negative w cubed, negative w to the 3n, to the 3n. I'm going to make it 8n. There we go. We have 8n. All right, now we're using variables. Same variable, we have to add them together. Are those like terms? They both have an n? Yep, I can add them. So my final answer will be negative w all to the 11n. So our last example is showing multiple steps. We have multiple brackets here. We have coefficients. We have numbers in front of variables. So you would multiply the coefficients. And then use your exponent laws on the variables. So I have a base of w, base w, base w, and a base w. Same base, I'm going to add all my exponents there. So I'm going to have a digit. Okay, that's my digit. my answer for multiplying all those coefficients, so the coefficients I'm multiplying are the 7, the 6, the 9, the 8. Remember, coefficient, the word co means in front. Okay, so that's why you're multiplying the numbers in front. So what do you get for those big, big numbers? Who knows that answer? Who multiplied it out? I would like that. So multiplying the coefficients, we get 30, 24. Next, we have our W. We sit W beside them. And now we're going to add all those exponents. 5 plus 4 plus 3 plus 6. Okay, so my exponents now, 5 plus 4 plus 3 plus 6. Those are all my exponents I'm adding. And that answer is going to go on top in the exponent part on the W. So how big is that exponent? Good, 99 is 18. Perfect. Second law is called the quotient law. Quotient means it's in a fraction. So in fraction form, possible. Because the fraction line means to divide. Okay, so the fraction line means divide. So quotient law, two conditions. I'll let you get caught up on those. The conditions are we need to have the same base, and we need to be dividing. It's got to be a dividing question. Okay, it's got to be a dividing question. If we have those, all we do, we're going to subtract. The exponents. Okay, so if we have same base and we're dividing, we're going to subtract the exponents. If there's coefficients, we divide the coefficients. Okay, coefficients, you divide them. If you get a run-on decimal, you math bracket and leave it as a fraction. So if your coefficient divides and gives you a run-on decimal, math bracket. What that is math, enter, enter. If I say math bracket, I want you to go math, enter, enter on your calculator. So this means math, enter, enter on the calculator. That's your calculator steps to do that. Okay? So divides gives you a run-on decimal, you math bracket and leave in fraction form. And we're going to be doing a couple examples like that. So you'll understand what that step actually means. We'll do some examples. I'll let you get caught up there. Here's a few examples for you. Example 1. 5 to the 6 divided by 5 squared. These guys are my base. We have the same base and we're dividing. So we're going to subtract the exponents. So I'm going to get 5 exponent 4. Now if it says leave it as a power, this is a power, the whole thing, or it's also called exponential form. If it says evaluate or simplify, that means you have to solve it. Okay? Evaluate or simplify. Means solve if possible. Okay, solve it if you can. So we would take our 5 to the 4 and solve it to get us 625. That would be our answer. Here's another example. Now we've got variables. If I've got W7, Z4, all divided by X6, Z. How would I solve a question like that? Got multiple variables. Multiple variables. How would you look at something like that? Take a wild guess.
You like solve the top first and the bottom first.
If you can, yeah. So you look at the top, is there anything that is the same? No. Look at the bottom, is there anything the same? No. Now draw in your hiding baby ones. This guy is a hiding one. Don't forget he's there. Now you're looking for something that's identical top and bottom. Is there something identical top and bottom? The Z's. So I can only deal with the Z's. This line means divide. So when I divide and the bases are identical, what do I do with the exponents? I subtract them. So this guy's going to give me Z3. Now, he always goes where the higher number is. That's how you know where to put him. So my answer's in fraction form. Did W and X go anywhere? Nope, they stayed where they were. So W goes beside and X goes in the bottom. They didn't move. That's why I put them in blue. Okay? They didn't change places at all. They stayed. But we simplified the Z's. Simplified means we wrote them once only with a different exponent. Okay? So we simplified these guys and squashed them together, and I got Z3. Now, if the bottom number, let's say, for example, was a 9. Let's say I've got Z4 over Z9. And on top again, I've got my W7, and on the bottom, I've got my X6. Okay? We've got a 9 here and a 4 here. Again, I deal with my Z's. The Z's are the same. If I subtract them, what's 4 subtract 9? It's a -5, right? So, I would be doing this. W7 doesn't move, X6 doesn't move. Yeah, what's your question?
Where's Z9?
I just brought it, I picked it off the top of my head. This question's done. I just did another example. Better?
Yeah.
Okay. So now these guys you subtract, you would get Z -5. Do we like to have negative exponents?
No, it's
So we write, exactly. We don't want the negative. So you always put them where the bigger number is, and then that makes the exponent go positive. So on top he'd be a negative. The bigger number 9 is on the bottom. So you're actually going to put the Z on the bottom with the bigger number, and then the 5 goes positive. So he won't be on top anymore. Okay? Do you understand that concept of why you would do that? Because you subtracted the numbers and got a negative. Whenever you subtract the numbers and get a negative, you put your answer where the bigger number is, either on top or on bottom, whichever they are. Okay? Here my bigger number was on the bottom, so my answer went to the bottom. Here my bigger number's on top, my answer went to the top. Okay? Does that make sense? A little bit? We're still on the next law. We're still on law 2, the quotient law. Now we're going to put some coefficients in. So we're going to put numbers in. Okay, so we're going to put some coefficients in. So if I've got let's go with 2, A5, B6 on top of, let's go 12 first. 4, A, B, 4, C, I want 2. C3. Okay. There's my question. When I look at a question like this, the first thing you do is you check your bases. Your bases are your variables if there's coefficients. So I've got an A and an A, they match. I've got a B and a B, they match. I have nothing to match with the C. So the C isn't going to change anything. He stays the same. So my answer is going to have C3 on the bottom. He doesn't change. He's taken care of. I dealt with him. Now I'm going to take my coefficients. The coefficients, you actually divide them. If they divide evenly, it's beautiful. If they don't, you math bracket. So 12 divides by 4 evenly to give you a 3. So the 3 will go on top. Now I've dealt with this. Okay, that became this. I've dealt with it. Now we've got to take care of the A's and B's. What's hiding on the A on the bottom? A hidden 1. Good. So you're going to take your A's, and what do you do to the 5 and the 1? Subtract. How many A's do you have left over? 4. Now, bigger numbers on top, so the A goes on top. Okay? B6. What do I do with my B6 and B2? Subtract. How many B's do I get? 4. All right. Is there anything else on the bottom beside that 3? No, exactly. So that will be your final answer. Now, yeah? No, he could be right in the middle on the bottom. I just left him over here to let you know that I dealt with him, and everything else over here that was beside him disappeared. Okay? So everything that was here disappeared in front of him. Okay? Now, sometimes that doesn't happen. Okay? Let's just, for example, say I put a 22 there. Say I put a 22. Now you're going to go 6 subtract 22 for this guy. So if I go 6 subtract 22, I'm going to get how big? Negative 16. Well, if I wanted to do that, my B up here would be negative 16. Do we keep B's as negatives or anything negative? No. So where's my big number? On the bottom. So where should this guy go? To the bottom then. So then this guy would go B16, and the 16 would change to a plus if I move him to the bottom. Okay, so he originated on the bottom, the big number, he will stay on the bottom positive with a big number. Okay? Because remember, we can switch things positives and negatives if they're in the wrong spot. So let's take an example of that, just to remind you of what's going on here, why I flipped him. If I've got 5 to the negative 2, I flip him to be positive, which means I put him over 1, and now I flip that sucker. And I've got 1 over 5 squared. This part changes to a positive. Okay? If you've got, let's say, 7 negative 4 over 3 cubes. Okay? Again, who's going to switch? Do they both trade places? Only the negative 1 trades places. So, you have the 7 to the negative 4, he's going to come to the bottom and become a positive 4. The 3 cubed is going to stay where he's at, sitting side by side. They mean multiply, but you don't have to write the multiply sign, because they should know that. When they're attached side by side, it means multiply. What's going to be left on top?
1.
A 1. Okay? So if you take anything off the top and you have nothing left, you have to put the 1 there, because I see a lot of questions where kids will just do this. Well, there's my answer. I got my answer. You dealt with all the variables. You dealt with all the exponents. There's my answer. That's not the correct answer. You took something off the top, which means you got to replace it with a 1. Okay? Is there any confusion on this part of why we switch negatives to the bottom or negatives to the top? Yep.
I have a question.
Sure.
Does it matter if 7 to the power of 4 is in front or behind the 3 cubed?
No. So you could have 3 cubed times 7 to the 4. Yep. Either order's fine. Now, what if you had a question like this? 6 negative 3 times W 5 all on top of 7 to the negative. It's going to be a negative 6. I'm going to make it a negative 6. 7 to the negative 2. And, well, let's go Z 4. With a question like this, all you're looking at is the negative exponents. And they will trade places. The negative exponents trade places. So, you're going to look at the negatives. He's negative and he's negative. They're going to switch places. So, we're going to have 7 squared on top and the 6 negative 3 on the bottom. The W and the Z stay where they are because they didn't trade because they had positive exponents. Okay? Does this negative sign disappear when I move them to the bottom? Does it disappear? Unless you get positive 3 now when he's down there. No, it doesn't. You have to keep that negative sign. This negative sign does not disappear. Now, in your final answer, where will the negative signs go? In a final answer, your negative sign will always float to the top, no matter what. Okay, so this is what you would get. And if it said solve or evaluate, you would solve this, you would solve this, and then you divide it in a math bracket. And the negative sign would float to the top. You cannot do anything with Z and W. How come? Different base. They're not the same letter. If they're not the same letter, you can't do anything with them. Okay? They're different bases. All right, let's take a look at the third law. This is power of the power law. This is where we're dealing with exponents outside brackets. Okay, this is where we're dealing with exponents that are on the outside of a bracket. Well, the rule says multiply the exponent outside brackets to all exponents inside the brackets. This removes the brackets. Okay. Okay, a couple examples for you. 5 squared over 6 cubed, all to the 4th power. This is where we get exponents on the outside. Okay? If we've got an exponent on the outside, he multiplies inside to the exponents, not the bases. So the 4 is going to multiply to the 2 and to the 3 on the bottom, not to the 5 and the 6. So my 5 and 6, oh, I get rid of brackets, pardon me. I get rid of brackets to do that. Now my answer is going to have a 5 and a 6. What are the exponents on my 5? Sure.
Why would we do inside the brackets first?
To solve it for bedmass, I'm just using this to show you the exponents rule once we start putting variables there instead. Okay, so this is just a beginner example. Okay? With bedmass, yes, you could solve and then exponent it. Absolutely. So we're going to get an 8 there. What do we put on the bottom? 12. Okay, 8 and 12, I can throw the brackets. Now we're going to throw some variables in. So, 5 dots, W6 on top of X4, all exponent 2. Now what am I going to do? There's nothing you can do to solve in brackets. Put the phones away, please. Phones away. You're pissing me off. Your phones. Is it calculator you're using? Okay. Good girl. Alright. What am I going to do with that 2? It's a cute little 2. What am I going to do with the 2? What do? I multiply him in. Good. So I'm going to multiply him in. So that removes brackets. I get W and X that come outside. Now what's the exponent on my W? It is so 12. On the X, what do I get? 8. Good. That removes brackets. We're done. Okay? Now, if you've got a coefficient in front, okay, we have to do it with a digit in front now. We use the same rules. Okay, have we done writing those examples? Okay. Here's another one. Aha. Aha. This one's a little tricky. Now, what are you going to do with this question? What do you notice about it? What makes it a bit tricky? Because you can divide 15 by 3, can't you? You can divide those coefficients. And you should divide the coefficients. Okay? So if you can solve something in the brackets first with BEDMAS, you're going to solve this in the brackets. So the first thing you're going to do is solve this part if you can. Okay? So 15 divided by 3, how big? 5 times. Good. So this is actually going to become 5x to the 4 on top of W2 all to the 7th. Okay? Because that 15 and 3 are going to make that 5. Now, what do I do to that outside 7? What does he do? What do you think he does? He's the outside exponent law. I got things in there. If I got something outside, what am I going to do to get it inside? I multiply them to remove those brackets. So now, I'm going to multiply this 7 into the 4 and into the 2. I'm missing something though. Yep. I do so. The 5 has a hidden baby 1. So it also gets the 7. Okay? If it was a multiple choice test, that answer without the 5 being solved would be a distractor answer. You can't forget that 5. He's got a hidden 1. So your final answer is going to be 5 exponent 7, x exponent 28 on top of W 14. Now, if it says leave in exponential form, that's exponential form. If it says simplify or evaluate, you solve the digit part. You will solve that part. Okay? How big is 5 exponent 7? 7 times. Nope, not times yet. 5 times 5 times 5, 7 times. So it's 5 exponent 7. Who has it? It's huge. Yeah, it's huge. What is it?
7, 8, 1.
That's it? Okay. And then x28 on top of W14. Okay? This number comes from that guy solved. I know it's a big number. Most of them will say leave in powers. If they say leave in powers or exponential form, they just want to see this part. Okay, with the 7 circle. Alright. Okay, we have a 0 exponent law. Okay, this one is going to be zero exponent law means any base with exponent 0 equals 1. Now, the kicker here is any positive base. It's got to be a positive base. Okay? Now, you can also have a negative base, but not a dangling negative. So any positive or negative base, but the negative's got to be in brackets. If the negative's not in brackets, it's going to be a negative one. So, an example. 5 to the 0 equals 1. Negative x to the 0 equals negative 1. Negative w in brackets to the 0 equals positive 1. The difference is because this guy has the floater negative. Okay, the floater negative makes your answer negative. That's just the rule. So you're often going to see another example like this, but it'll have the negative sign up front, a dangling negative, the floater negative. So if you had something like this, I'll move it up. If you had another example, negative x to the 0, I'll even put a 5 there, it doesn't matter. That's going to give you a negative 1. Okay? Because of the floater negative. This part gives you a positive 1. This gives you the negative 1. Okay, I'll give you a chance to write that down. It says negative exponents must be changed to positive for final answer. Okay? And in order to do it, how is that going to happen? You flip the negative exponents bases to opposite place. Opposite place in a fraction. That's important. That makes the exponent positive, not the base. So if that base has a negative sign, the negative stays with the base, but the exponent will change. Okay, and we'll do a couple examples. I'll give you a minute to write that down. Okay, here comes the examples. Example 1. Okay, there's my example. Does everything trade places top and bottom? No. Who trades places top and bottom? Only the negatives. So the two I'm going to change, and they're going to trade places, are those two. Those two are going to trade places. And when they do, their exponents become positive. Okay? The other ones don't change, they stay put. So my final answer, the 6 squared didn't change, the 7 cubed didn't change, the other ones did. So I'm going to have an 8, exponent positive 1, I can hide it if I like, and I've got my 5 exponent 4. That made my exponents become positive the minute I traded them places. Okay? Does this part make sense? Okay, let's put some variables in there. And some negative bases. So let's go with negative w to the negative 4 z cubed over x squared y to the 5th. All right. What happens here, kids? How am I going to move that one? What do I do with a question like that? What's the first thing I look at? What do you think? Put W on the bottom? Okay, absolutely we do. But how come? Because he's negative. Does anything else change? No, the other guys don't change. So, I'm going to have Z3 up here. I have x squared and y5. They didn't change. My W4 is coming to the bottom. Does it matter where I write the W4? Nope. You could go here or here. Doesn't matter where you put them. Okay? Now, up beside this guy, my W4 was negative. This means this guy's negative. My final answer is going to be negative. So where does my negative sign have to float to? The top. So this has got to be negative. It just means your whole answer will be negative. Okay? Because it's a floater negative. This guy stayed on top. Okay? This guy stayed on top. Because floater negatives always go to the top in a fraction. Last one can be a bit confusing, so please pay attention. Our last law is number 6?
Yeah.
All right. So this one's called radicals. So fraction, exponents, and radical form. So, fraction, exponents, and radical form, anytime you've got an exponent that's a fraction, you can convert the fraction to a radical. Okay? So, my example is x to the 2/3. X to the 2/3. How am I going to make that guy into radical form? The exponent on top stays with the base. Okay, so the exponent on top stays the base. The guy on the bottom becomes the index. Of a radical. So it becomes the index of your radical. That's how you're going to put the x under the root sign. So, we know for radical form we need to do this. There's my radical. Okay, so my final answer is going to give me this. The x is here. Where does the 2 go? On top of the x. He doesn't move. He stays with the base. Where does the 3 go? The index checkmark part. So this guy goes here, 3. Okay, and that's all you do. Okay, we'll do a couple more of those. Is that pretty clear on how to change those? Let's try again. W to the 7/8. W to the 7/8. Write your check mark, your radical sign, W exponent something comes in there. What's my exponent on my W? 7, the top number. Who's my index? 8, good. This guy goes there. Okay, yep. Aha. That was our next example of the negative fraction. Okay. Ready? Okay, next example. X to the negative 2/5. X to the negative 2/5. The first thing you have to do is get that negative exponent gone. It has to be a positive exponent. So you need to flip it. So you're going to put it over 1, and you're going to flip it. Okay? So you're going to have 1 over x to the 2/5. That makes this guy become now a positive 2/5. So now when you put it in radical form, it's going to be in a fraction. The radical will be on the bottom. So now you're going to have 1 over the root sign x. Who goes on the x? Which exponent? 2. Which guy goes in the index? 5. Good. That guy goes there. Okay? A little better with the negative exponent? Okay, let's work backwards. Let's go the other way now. We're going to start with these guys, and we want to be able to get that. Okay, we're going to start with radical form and work backwards now. Okay, that's our next step. So this one's going to be radical to exponential. Okay, so radical form to exponential form. We just undo the steps we just did. Okay, so we do the opposite. So if I start with 4th root of x cubed, I write my base. Okay, because that's my base. You write your base. What does your fraction exponent look like? It's going to be a fraction. Who goes on top? 3. Who goes to the bottom? 4. All done. Okay? Let's do one with a negative. Okay? So let me write that down. Last example. Last example. We've got 1 over 7th root of w cubed. I like 3s and 7s today. How are we going to change that one to exponential form? What am I going to do to that one? Do I want negative exponents? Never. You don't want negative exponents in your final answers. So do I have to flip it? No. Don't flip it, because you want your answer in positive exponents. So all you're going to do is do the same thing we just did to this guy. So we're going to have 1 over w, and he's going to have an exponent that's going to be a fraction. So what number goes on top of the fraction for the w? 3. What number goes to the bottom? 7. Beautiful. Now if the question did say, put it in negative exponent form, you would just flip this guy to the top, and it would become negative 3/7. Okay? The fractions are usually put in brackets. That is the whole exponent laws lesson. You know all the exponent laws now. This concludes exponent laws lesson.